Solving the problems in the absolute value packet I gave you earlier this week. So anyway, this is going to be dealing with absolute value, and this concept doesn't look like it's tested too much on the SAT, so what you see here should be sufficient to do well, because I know this concept can be a little tricky for some people, um, me included. This isn't my favorite mathematical concept, but it's really not that hard. And basically, it just revolves around this concept is that you have these horizontal bars and they're around something, and they always give back a non-negative number. And what do we mean by non-negative number? Well, whatever value this ends up being here circled in blue will be greater than or equal to zero, right? So it either be zero or it's going to be a positive number. And you could think of this number here, again, the one in this thing circled in blue as distance, right? As distance from the origin or distance from zero, right? So if I have, um, the absolute value of x equals 5, you can think of it as starting at 0, right? And we go here, right? So you have 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. Of course, so here you have -5, and here you have +5. So let's say, this is you as a person, right? And you want to walk, right? And, let's say there's, I don't know, a movie theater here, and then you have a restaurant here, right? So you have your restaurant, you have your movie theaters. If you want to go to the movie, or do you want to go eat, right? So you go either to the right or you can either go to the left, right? So there's two ways you can go here, but both places, right, are five distant. Well, let's use 5 miles away, right? So if you go to the movie's 5 miles away from home. If you go out to eat, that's 5 miles away from home. We can consider it negative. It's like, let's say you have to go backwards, right, from where you're facing, and positive would be forward, going forward to the movie theater. But the distance is the same, right? The distance is 5, right? 5, in this case, 5 miles, right? So if you think about absolute value, it's just distance, it's going to make things a lot more clear, right? Just think of it as something that's positive, because you can really never have like a negative distance. What does it mean can you imagine being like -6 feet tall? I don't, that doesn't make sense, right? Uh, so think of absolute value as distance, and a lot of these problems uh, are much more easily managed, right? So let's look at this. Let's look at this statement, right? We have a statement that says the absolute value of x is less than 4. So that's how you would read this. You would see the horizontal bars, right? And you would know, okay, I'm dealing with absolute value. I would say absolute value of x is less than 4. So what does this mean? This means, like, if we go back to our example, right? We go back to our example, right? Let's say, you're here on the line, and, right, uh, like, let's say, for whatever reason, you're in a car, right? Or, yeah, I can't draw a car very well, but let's say you're in a car, and, you have enough gas to get somewhere that's less than 4 miles away, right? So you can't go more than 4 miles. So 1, 2, 3, 4, 1, 2, 3, 4, right? So you can either you go up to this point here, -4, to this point here, 4. And by -4, we just mean the direction, right? Like I'm going behind, right? So let's say you're facing this way, right? So your eyes are facing this way, so negative would be this way. Your eyes turned around, right? You're turning around, and that's where you were going. Okay, so here we are, right? So you can only go up to 4 places. So you can go, let's say you have a friend's house here, right? You have, let's bring back our movie theater. Let's say you have your movie theater here. I don't know. Let's say there's a burger joint over here, right? So if you want to get something to eat with your friend later, it's past his house, right? So all of these places, if you notice, are within 4 miles, right? So you can go to any one of these places. You can go to a movie, you can go see your friend, you go get something to eat, right? They're all within. But let's say, right, you have a place over here. Let's say this is a gym, right? You can't go here because this is, let's say, -6 units away, right? And let's use the units as miles. So this is -6 miles away from where you're facing. So you couldn't go here, right? So if we go back to our statement, right, any one of these places, right, let's say this is 3.5, and this is 2, and these are all minus, and this is positive 3.5, right? So any of these places are within your distance that you can go to, right? So you could plug in these numbers. You could say, okay, well, can I go here, right? Can I go So negative 3.5, I mean, that's less than 4, right? And that's true. That's a true statement. But what about, like negative 6? Is negative 6 less than 4? And that's not true. You can't do that. Um, so that's, again, that's one way to think about it. So let's look at the values that do that. So basically, you can think of the values of x that make this true, that make this statement here in blue true, as being, let's call this 0 and call this positive 4 minus 4. It's any value within here. And notice I'm using parentheses instead of hard brackets. Hard brackets mean something else. We can talk about that. Parentheses mean open. So they mean up to, but not including. So any value up to 4. So this would be, if you have negative 4, 4, you would have 3.8, you would have 3.9, 3.999. Right? These are all values that you can go in there. Of course, you can't have 4, right? So any value of these x's here make this a true statement. They make a true statement, right? It's like asking yourself, how far can I drive, right? I can drive up to 4 miles south and up to 4 miles north. So that's kind of like the way we're going to be thinking about this absolute value. So now let's look at solving some, right? So let's say you have x plus 1 less than 5, right? Now it says, how many integer values satisfy this? Or basically, how many integers, right, would satisfy this? And of course, integers are whole numbers, right? So we're looking for how many whole numbers will satisfy this statement or make this statement true. So the first step, what we want to do is you start with this. You almost think of dissolving those horizontal bars, but to do that, you have to put the negative 5 here, right? So then as soon as you do that, you just solve like normal. So you would subtract 1, subtract 1, subtract 1 to get rid of this 1 because we want x by itself. So then you minus 5, so this becomes minus 6. This is x, and this is 4, right? So what does this say? So, right, I have this. I started with this, right? But what does this mean? How do we interpret this? Well, the way you interpret it is you say let's say this is 4, this is 0, this is negative 6, right? So the way we interpret this, and these, when you see these like this, and you don't see this, this means you can think of it as this. This means bracket. Again, we'll talk about brackets and parentheses a little bit later, but right now we're dealing with brackets. So we're going to put a bracket here and a bracket here. So any one of these x values, right? These are all x values. You can think of this as the x line, right? Any one of these x values, you can plug into here, and this will make it a true statement, right? And let's try it. Let's try the easiest one, 0. 0 plus 1, 0 plus 1 is less than 5, right? Because this is just absolute value of 1, right? Yeah, and that's true, right? That comes out to be 5, right? Yeah, so that's true. And if you plug in another number, let's do really close, so like negative 5, right? So negative 5 plus 1, what is that? That is, let's see, that's negative 4. Of course, the absolute value of negative 4 is just 4, because whatever's on the inside, you just get the positive of, and that's less than 5. So yeah, so like we said, any one of these values will work here, as long as it's open. Because if you plug in 4, you get 4 plus 1 is 5, and 5 isn't less than 5. So that's why it's crucial to have those open brackets, or sorry, open parentheses instead of brackets. So of course now, if you just given, what does this graph look like, right? Let's say you have, what does this look like on the XY axis, right? Well, this just looks like, right, what's this? Let's think of this really quick, right? This is x, right? This is if f of x equals x, right? This is your function, and you have 1, right? You get 1, and if you have 2, you get 2, right? So you just get, this is just f of x. But remember, cannot be less than 0. You can never have this less than 0. So all these values here, right? This is a negative number, that's a negative number, that's a negative number. It can't be there. So what happens is, you can think of it, it almost gets like pulled up this way. So I'll draw the dotted, what it should look like. I'll draw the dotted. This becomes pulled up, right? You can think of somebody pulling that up and saying, no, I don't want this to be negative. I want positive values. And they're still the same values. Like if you plug in negative 1, right? If you plug in f of -1, you would get -1 here, right? This is -1. But if you plug in absolute value, if this is your new function, right, you say absolute value of -1, you get 1. And that's what happens. -1 here goes to positive, or should go to +1 right here. So in reality, your new function, or your new function will look like this, right? So that's just where this is what this looks like. And then from here, you can do all your transformations, right? You can do +2, which you would just move it up, right? -2, right? Then you would say, well, wait, didn't you say the absolute value couldn't be negative? Now, this is never negative, but when you add stuff to it, you can make it negative, right? When you add a -2, you shift the entire graph down, but you're not changing that. So that's a kind of a point they may get you on. They may say, well, wait, what about that? And yeah, that's essentially it when you're given a function like that. That's how we should think about these absolute value um, questions, and looking at homework. Um, right, so if you're given a function like f of x equals 2x, right, you can always do, right, so you can do you can do this, and this will be the same thing as just doing this, right? So whatever value you plug in here, like if you plug in f of -1, you'll get -2. Well, f of -1 here, the same thing as doing -2, which is +2. Do you see how here it's just the difference between a negative and a positive, right? So it's just a sign switch. So just remember, if you want to do the absolute value of a function, you just put the absolute value around the entire function, and you get you'll be able to get that. Let's go over the brackets real quick. This pair, and this pair. So if you're seeing this is the same thing as doing this, and this is the same thing as doing this. And it's real simple. Like you may ask yourself, well, what's the big point, right? They look basically the same. Well, if you do this, right, and let's say this is 3, this is 3, right, this is 0. So this means that it includes it, right? So if you see these, they include -3, 3, right? So if you have x less than or equal to 3, right, what this means is that you have -3 less than or equal to x. Less than, -3 less than x is less than or equal to +3, right? So you actually you would include 3 in the x values that satisfy this right here. So you can plug in -3 and make this a true statement, right? Now if we had x less than 3, you would have -3 less than x less than 3, right? So what would that look like? That would look more like this. That would look like these brackets here. I'm just going to close this real quick. These brackets here would look like this. This would be open, this would be open. What does that mean? Well, that means that you can't put in -3 here, right? Because let's say you could, right? Let's say, well, I don't believe you. There's no difference. I say, okay, well, -3 is that, sorry, absolute value of -3, right? First, you would plug in your -3. You would get absolute value of -3, which is just 3. So would you say, right? So you're saying 3 is less than 3, right? What does that doesn't make sense, right? That doesn't, 3 is less than 3, no. Now you can say, is 3 less than or equal? And that's when you draw your little line for equal 3. And you say, yes, yeah, it's equal. It's not less than, but you said equal, so I'm cool with that. But when you leave this sign, 3 less than 3? No, it's not less than. You have to have or equal, right? That's just real careful when you say or equal, but you kind of like run it in there real quick. I know I do whenever I'm saying, oh yeah, x is less than or equal, right? So it is, if it's equal, right, and that's where you draw that line, you're good. That's about it for that. I mean, that's about it for the solutions. They don't look like they grill you too hard on those, so don't worry, but that's good to know. I guess I'll do one more. Looks like you need this technique to solve. If you have something like 2x minus 2, you can always pull out this 2. You can factor. And the way you factor is you can just pull out the 2 here, right? Right? We're cool with that, right? I'm just pulling out the 2 from here and here. But when you have a product, if you have AB, it's the same thing as doing A times B. Actually, let me write it over here so it's clear. If you have A times B, where it's two numbers, two variables, whatever, I can do absolute value of A times the absolute value of B. So this statement is the same thing, right? So what do we have here? Well, we can call that A, and we can call this thing in purple B, right? So really I have A times B, right? Let me fix that, right? Which is the same thing as A times B, right? Because we're using this property here. Now, let's be careful, right? Because this is cool. What is our A? Well, your A is 2, right? So I'm getting the absolute value of 2. And what is our B? Our B is x minus 1, right? So it's times x minus 1, right? So now, of course, the absolute value of 2 is just 2. And this is still x minus 1, which we're not done with. We haven't solved yet. But the crucial part is that we can take this number out and divide, right? So if I actually had set this equal to like 4, I can now divide that 2. I can pull this over here and divide both sides by 2 and get x minus 1 absolute value equals what was it, 2, right? So that's just, remember, you can factor this stuff out with the absolute value. But I'm looking at the rest of your problems, and they all look like you guys probably didn't even need to know this, but it's good to know. This is good stuff to know. I don't see them stressing that. But I'll throw some more problems on there because I know absolute value is tricky. And practice makes perfect. So anyway, I hope this helps.